My name is Anupam Singh. I'm one of the co-founders of Explain.io. How many database people in the house? I saw at least 2 or 3. Of course. Yeah. Okay. 2 or 3 database. We talked about, so a couple of questions already came up, right? Schema-lessness, you complimented Justin on that. I compliment Justin every day on that. And then the other one was, he asked that question on whether I should throw away all my old databases and just, win Hadoop and run it on Impala as it were, right? And again, Justin answered that question the way we have come to, right? There's no one place or one query language or one query processing engine that can solve the problem for you. Even in olden days, you had Sybase for OLTP, you had Oracle for something else, and Teradata for data warehousing. So it's not something that we advocate, that there's one SQL processing engine for everybody, right? We are taking it one step further with the integration of Explain technology in it, right? So that's what I'll talk about. Those 2 or 3 questions is one of the main reasons why Cloudera brought Explain into the product portfolio. So how did we end up building this product? Even though we like to talk about queries, we like to talk about schemas, etc., whenever you go back to business, they're only talking about their dashboards and reports showing up on time, right? That's what they talk to their BI team, that's what they talk to their architect saying, okay, is my profitability report showing up every day? Or, or my marketing funnel being built every 48 hours? Now the database people in the room and other people in the room know that behind that is a big honking database, right? Especially even if you're a
No, we've discussed this. It's magic.
It's magic.
Or 100 of them.
Or 100 of them, right? Yeah. And keep that in mind, the 100 database figure. We'll come back to that in the demo. So what's going on between the 2 worlds? You fire queries, you get answers, right? That everybody knows. Our insight was that companies have always been data oriented, especially any Fortune 500 company worth its salt has a data warehouse, has a BI platform, and all of that activity is getting logged through the queries that are being fired every day. So we built Explain not to mine the data. We decided to data mine the queries themselves. So if there's one thing, if you remember about Explain, it's afternoon, things are quieting down. So if there's one thing you want to remember, it's we mine the queries, not the data. We are trying to find out from this thing that you see on the screen, right? Whether we can build an enterprise knowledge hub. Okay, so any wild guesses on how many tables in an ERP system? Just tables.
Oh. Some of them are tens of thousands.
15,000, right? Yeah. In a healthcare system, there are 245,000 columns. 245,000 columns. And when people say, I like to look at all my data, I'm thinking, okay, so looks like you look at 245,000 columns every day. That's a very, very big spreadsheet, right? So we founded Explain, and then our entire data management suite that we keep talking about, Justin, Alexander talked about, right, is we have to make sure that the use case fits with the SQL processing engine and even further, right? Use the right technology for the right problem by looking at your current data usage. So we mine the queries, we find out what data you like, what is important to you, and then use that to build your underlying Hadoop system. The tool might recommend Impala, it might recommend Hive, it might recommend HBase, and if there's a lot of access which looks like search, it might take you all the way to Solr. So we look at the current queries and build a system. Okay. In the end, we are trying to establish from that knowledge hub this notion called business intent. What do the BI analysts really look for every day? We are creatures of habit. We happen to run the same reports with the same filters again and again and again. But most of us are attracted to that big number on how many reports are being run by the BI system, how many queries are being generated by the ETL system. Okay, so that's the basic premise behind the product, and that's it. So what does it look in real life? What does this look like?
A jumble.
What's that?
A jumble.
Yeah. Anybody else? It's actually a SQL query. We always talk about SQL, right? I wonder sometimes whether people actually know what a SQL query in the wild looks like.
I would call that atypical.
What's that?
That's a special one.
Okay. So, so we keep running into queries like this pretty much every day.
That looks generated by something.
Absolutely.
Likely. It's like a likely hibernate, and it's probably a cursor, and it's every
Or
bad
it's
practice.
Some sort of
Nested views, maybe?
Nested.
ORM system.
It could
maybe.
be a function. It could
So
be
business intelligence tools.
Yeah.
Business intelligence tools.
Yes. Oh yeah. Anything generated
ETL.
looks like that and is ugly.
absolutely.
And there's the third biggest thing that generates very nasty queries. People. Okay. So
People
you'll
don't type that much, so I know that's not a person.
you'll write a query, and he'll come in and add a little bit of business logic to it, right? There are queries that have been run for years. There's a customer of ours who came in last week and said, hey, there's one query, we want to rewrite it for Hadoop. Of course, one query, even I got finagled into it, right? It was 22,000 lines. Cut and paste, cut and paste, cut and paste, right? And what does it build? It builds the marketing funnel for this very, very big company. So it's not a trivial query. It is not a science experiment. It actually builds your sales funnel, you know, sales leads, calls, emails answered, etc., etc. So we thought there must be a better way, because we found ourselves looking at these queries pretty much every day. Right? Customers coming in and saying, hey, I have this query or set of queries, build me a Hadoop system. Okay, right? You know, what does that mean? You have to choose between Hive and Impala. You have to figure out what the schema looks like. You know, schema-lessness is not true, right? So schema.
It's true when we get the data. We just schema later, not
Yes.
schema less.
Yes, and schema on demand. There's lots of words for it, but in the end, some of us are in the boiler room building those tables and figuring out, how do I partition this table? Should I keep it in memory? Should I even keep it in Spark RDD, or should I keep it as a high partition table, right? So we said, we go into customer sites and say, let us look at your current queries to first figure out where Hadoop, big data, MapReduce, all of these words fit in, right? So we take their current queries and we create something that database people will know very well, an ER diagram. So anybody who's done database programming remembers, you know, you draw these tables, and ideally this table should join with this table. And as soon as the ink is dry on that ER diagram, it's violated by somebody else who writes some other query. So you build an idealistic diagram, and of course it goes, you know, for a toss as soon as it is in production. What you see here is an ER diagram based on usage. Any column that shows up is important. We are not deeming it important. The business runs these reports every day, right? So in this particular case, if people can make out, this table is called CRM customer locations. And the main table that it goes against is CRM service contract. This is a business which is service contract based, and it is very interested in the locations of their customers, right? We used to be a little apologetic about this screen, in the sense that every business that we walk into, right, should know all this, right? But there's so many people who combine and collaborate to build these systems that there's no one place they can go and say, this data item or this set of tables are interesting to the business. Okay, so that's one of the first things that we do. We don't look at data. We do not look at the schemas, and we don't need any statistical information. We derive all of this just from plain text SQL queries. So we don't need a connection to the database, or whichever database you're at, whether it's a Hadoop-oriented database or a relational database. We then look at things like by analysis. So every other report in this particular case is run on customer locations. All the other things, all the other tables are not that interesting. And this holds true for almost every customer site that we walk into. Some tables, some columns, some operations are more important than others. And that more important defines success or failure of that BI tool. These are the columns that everybody is interested in, so maybe these should be promoted into in-memory. These should be in the interactive system. Okay, so that's the first insight that we give to people.
I was just wondering, one thing that I'm missing here is if you have your batch reports that run every day, whatever, nobody looks at the output from there, but they're scheduled. So you're missing something out in here.
Oh yeah, so I can talk to that. This is the joy of working with real workloads, right? We have a customer whose fact table has around 200 or 250 columns, right?
Yeah.
250 columns, and business says, or their counterpart says, or there's an urban legend in the company that all columns are important because they're all my children. 250 columns, right? Okay. When we run these reports, when we look at their interactive BI workloads, turns out only 5 columns are really being used. It is expensive to maintain the other 245 columns. You're running massive ETL job flows to get those columns ready. Whether it is transaction amount, whether it is, I need data by zip code. But the end users, the BI customers, are not looking at it at a zip code level. They keep looking at state. So either you pre-aggregate that information, or you stop ETLing some of the columns that are not needed by business, right? Focus on the ones that are important. So what you said is absolutely true, right? There's a lot of ETL going on for data that might not be important to the business. So we don't do eyeball tracking it, but at least we look at the queries and we find out whether those columns are of interest or not. Okay. Now, if you can see the second screen, right, of the tool, this is another one of our favorite insights. Again, motherhood and apple pie, but that's what good insights are generally, right? It is a proof of some gut instinct, right? You see this skyline here, right? These are their fact tables. So they have 30 odd fact tables in that business. But only 2 are really, really, really important. The others are not important. Maintaining fact tables, replenishing them every 6 hours because apparently they're super, 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 super important, right? Versus finding out the 2 most important fact tables is a constant discussion that's going on between data architects and their counterparts, their business counterparts, right? So we go in, we get these queries, and we create these insights on how are tables being used, what tables are important, right? Couple of data points for you. Healthcare company has run 6.2 million SQL queries in the last 60 days. We are analyzing those queries for them. 6.2 million. So we thought, okay, we've seen everything, 6.2 million. We're talking to a financial services company. They ran 2.9 million queries on 22nd April this year because she was showing us, their dashboard. 2.9 million queries a day, right? Across a lot of their systems, right? This is not just one table, one system. But invariably, we find that some tables are very, very important. So the immediate question is, so what is business doing with it, right? So if you click through, you'll realize that there are, let's say, 756 queries fired on that table. Then another gut instinct that people have, having worked with databases, is not all of those 2.9 million queries will be unique. We are creatures of habit. So we fire off a query, and then my query might be very similar to yours. But it will be similar, it won't be same. You might have a different filter, I might have an extra column, you might have an extra dimension. So we're trying to find a core of the queries that are very, very important to the business. So around 99 queries are semantically unique. So what you're seeing here is a SQL compiler which does everything but executes the query. It analyzes it, it breaks down the queries into cores or pieces that are repeated again and again. And all of this is feeding into our systems to make sure that if we build an Impala system for you or a Hive system, it is informed from what is important and what should be optimized. So we are trying to get close to the needs of the business rather than just saying, okay, here's a big honking Hadoop system, put your tables in, copy the data, and Godspeed. Which has been the big data community's challenge, right? So then column usage, you talked about it, right? Column usage has a very strange habit of the first few columns are important and then it just drops off. This is the long tail of columns, right? That is when we say maybe some of these columns should be promoted into a column family, right? Some of these columns should be not even ETL. Again, this is information that is known at a gut level by a lot of people in the database groups, but they don't have a quantified way to look at it. So customers use this screen to go back to business, says, the last time you queried credit amount was once.
And that was a mistake, likely.
And that might be a mistake.
Can it tell you when that was? So
if they give us the timestamp, right?
Okay.
But
as you only used it once, it's like, yeah, you used it once by mistake 6 months ago.
Yes.
Kill it.
Yes.
Well, or the classic thing is it could be seasonal processing, it could be end of year, special stuff, tax filing.
Yeah,
so this is the whole thing behind analytics. You don't just look at the data and then start dropping stuff. You look at the data and then go find the story behind it to find out what you should be doing. And maybe it should be in another database that's only there for the end of year and not loaded every day, every night, something like that. Yeah,
the irony is the DBA profession is going to make a roaring comeback if ever there was any misimpression that people had that you don't need a DBA because now you have Hadoop data lakes, right?
But most DBAs don't care about this either, so you need to be saying data architect, because that's what we do.
Fair enough. Fair enough. Absolutely, right? DBAs are just a lot of times.
Well, don't say just. We love them, but they don't just care.
So that's where customers are using this information, right? They're giving us queries, and we then come back and tell them what's their most important tables, and within those tables, what are their most important columns, right?
It's interesting that you use the word important now, because every time you've used that, I've kind of made me itchy. Because, important seems like kind of the wrong word. I mean, it's used, right? In your story, it's like a heat map for your data. What data is being used? When is it being queried? How often? By how many people? That's an important thing. But I don't know if importance is the right word. So I'm wondering why is there a specific reason using that word?
Yeah, you were going to respond?
Well, it could be, because it could be a hotspot, and it's like, actually it's wrong. The reason that this is all slow is that you're hitting the wrong column, which has no index on it, because you shouldn't be querying that. What are you doing?
Or at the wrong level of granularity. I mean, there's already a year to date, but you're hitting all the months. Yeah. And the reason you have 250 columns in a table is because you've got, 5. I mean, this is how you do data warehouse design. Mm-hmm. You repeat all the months. I mean, repeating groups are your saving grace in a data warehouse design. So tables are very wide, but it could be that there's already an aggregation that should be used and the queries are actually wrong. They just went to the wrong granularity. But there could be really important data that's used for compliance issues that people don't usually query, but it's still probably keeping your CIO out of jail, making it very important.
Yeah, when you put it that way. Jail and CIO, I can't dispute that. But why do I use important, right? A lot of people are being asked to use new technologies, right? Let's put the right stuff in main memory, which is a great rallying cry at, let's say, a CIO level, right? But after that, what is the right stuff, right? It's the thing that is getting queried a lot. Let's partition the data correctly. Of course, nobody wakes up in the morning to say, I'll partition my tables badly, right?
I'll just be agile about it.
Or agile, yeah. Agile, schemaless, optimal. These are all great things to say, but somebody has to do the work of identifying what's to be promoted or what's to be, extracted out and put into a better RDD, right? Sometimes I have issues with the Spark community, which says, if you put data in main memory, you can query it fast. It's like, wow, I didn't know that. 20 years of databases, nobody told me that if I keep data in memory, apparently it can go fast. But you have to ask yourselves, what data should I keep in memory, right? That's like materialized views. If I materialize the right aggregates, then my reports will run fast. But how do I know that, right? So that's why we call it important, because our customers start treating these columns as important to the business, right? But there's nuance to it, right? There's if you go deeper into databases, you want to find out things like, what are they doing with that column, right? Are they aggregating it? Are they do they have a lot of subqueries? Do they have a lot of filtering going on? Filters are a great sign of sometimes saying, oh, the business is really interested in last 3 months of the data. Because you put a 40 terabyte table together. The first thing that the analyst comes in, puts a filter on the BI tool and takes out data for the last, you put 5 years of data together and takes only 2 months of data. So what operation is the next level of information? So we don't leave the user saying, okay, this is used, we're not going to tell you how it is used. Right? These are the operations that people are doing on that data. And then our users, a lot of them want to use Hadoop the right way, right? These are enterprise data architects, so they want to use Hadoop if it's appropriate for that particular workload. We give them early indications of compatible and incompatibility of queries. We actually run each one of the queries passing through the system against Impala and Hive to check whether that query will work on Hive or Impala, and then try to isolate the errors. Right? Sometimes it's just legacy SQL syntax that we'll not support because it's not ANSI, but the customer has 100,000 queries with that thing.
Yeah.
So it's our job to give them a suggestion on what to do with for folks, database folks, plus type joins, right? So that's the dashboard that you'll see. We also give them the top dimension tables, right? And all the operations, top queries by instant count. Again, just telling them what's going on in the database, right? Are you joining the data? Are you grouping the data a lot, etc., etc. Any questions, observations?
All of this is done at your location.
All of this is done in as a web-based system.
As a web-based services off of your...
Yes.
Okay.
Yes. Yeah.
Are you thinking of creating a hardware appliance that would reside at your...
No. Is there any specific reason?
No, just...
Okay. No.
Some people might be skittish about...
Yes. So if it's privacy reasons or if it's governance issue like HIPAA compliance, etc., we have a portion of this product that we deploy in the data center to anonymize the queries. So we remove all the literals from the queries if the customer wants it. Couple of customers have asked to scramble the tables also. So at least one customer scrambles the table names on their side,
Just the table structure, not the data.
not the
They
data.
don't get any of that.
No, we don't get any data. Till 2 months ago, we were a small company, so there was no way anybody was going to give us data. And we didn't want the liability of having healthcare data flowing through our system or financial services data. So we don't take any data in. We built the entire product not wanting to look at the data.
I mean, I think this is interesting because I've always been an advocate of using all these great analytical tools that IT is trying to tell you business how great it is, and then we never do analysis on our own IT things ever.
Yeah.
And that's really what this is.
We mine the
It's-
data but don't mine the queries, which is super counterintuitive.
Well, but we barely even use like even data visualizations to manage our IT systems.
Yeah.
We use command line interfaces and gut feel, and everything we tell the business they're doing wrong, we do for our own business.
But that you know what you're doing and they don't.
Yes,
so-
exactly. It's that arrogance.
Well,
I mean,
Partly the
professionalism.
tools haven't either the tools haven't been there or they've been awful because I've hand grown data
Right.
visualization things
Yeah.
to layer on top of like Oracle tools and stuff.
Well, that's because we
that
use
was like,
proprietary tools that
Yeah.
don't normally to manage our systems, like query tuning
Yep,
and data rationalization. We use specific proprietary tools, which makes it hard to do analytics on top of it.
Yep.
Yeah.
And they suck.
How sophisticated are the algorithms that are pulling this information out? Obviously, the first level is just kind of a grep. How many times are things
Absolutely. We compete with grep a lot.
There's some
But
regex.
But in all seriousness, we started the company with a bunch of SQL optimizer folks from IBM DB2, Oracle, Sybase, Informix, right? So we've written a SQL compiler. Everything that you see is actually being run through our proprietary SQL compiler. So we're building entire SQL trees, we're building entire join graphs. So we've invested a lot of our capital in building that SQL compiler. So we're not grepping. We had a customer last week who said, "Oh, you knew this is a temp table because it's TMP." I said, "Come on," but or dimension tables because they have dim in it. As a matter of fact, we sometimes take dimension tables and we say you're using this like a fact, and our algorithms tell you dim_date is a fact in your world. Customers don't like that, but still that's what the algorithms are for. So teeing off from that, there's how much time do we have? 2 minutes, 3. Okay. So a lot of times, right, customers might use the incorrect technology for their use case. So for example, here's a warning sign, right? It's a snowflake join. It's too many tables being joined left, right, and center here, right? You have to be very, very careful trying to do this on Hive, let's say. Okay, right? But then there are some queries which are not that bad, right? So let's look at this one. It's a straight star join. And Justin loves this join, right? Because it's got 6 tables, it happens again and again, right, in the workload, and it's pretty heavy. This table is the transaction table. This is how they build their receivables from the transaction. They take the date, the customer locations, the accounts, and the products, right? So when we find such nuggets where it's repeated again and again, they become a key part of figuring out a Hadoop strategy around that. So some things we analyze, reverse engineer, and say this is better where it is at, while some things we look at and we say, oh, you could actually take this into a newer system.
In terms of customer benefit, these kinds of tools, sometimes the kind of things you run on your system and there's an immediate, it sells itself, right? Because there's like 3 things already that the customer sees, like, oh, I should be doing this differently. Do you get that kind of example?
Yes. So generally, the first 2 screens, if this were your queries and your workload, ignites a discussion that generally goes on an average for 2.5 hours. I told you so, or this table is very important, half the columns are not. Many a time we don't get to this in our first meeting. First 7 days. We've had customers who give us 2,000 queries to start with, and the next day they FTP a file with 1 million queries. because they see in the 2000 queries some things that they either had intuition or they didn't know, and that's lighting up a discussion, right? So that's the first benefit. Now, some of them actually compelled us to build a workload assessment report. It's like the state of the union of your database infrastructure, right? How many tables are being used, how are they being used, etc. So we now do our initial usage as just giving the workload assessment report to them. And sometimes they find very crazy stuff like 675 queries with 56 column group bys. So anybody who's seen a query or written a query or performance tuned a query will see 56 column group bys cannot be fun on any system. But when you actually look at the tables and the columns, it makes sense. Somebody has very creatively built that report, and now everybody else is using that report. So again, we want to try that out on the new system, trying to find out how will it perform, right? I'm almost out of time. I'll quickly show you what you can do. Let's say if you have these selected queries, you can go all the way to showing how those queries will work, let's say on Impala. How many tables do you need? Because if you have 15,000 tables and you wanted to kind of figure out what do you start with for Hadoop, right? That would be hard. So these 5 tables, these 37 queries, right? And we start literally like you'd think of Eclipse or other tools. We generate the schema. We are not schemaless. So we generate the actual schema, the create table commands, the transformation commands to take all of these tables and maybe denormalize them. So take these 5 tables and create one table out of it, because that works better sometimes, right? So we are telling our customers you might have to restructure your data model to work on Hadoop, or restructure your data model simply because it's used like that. Then we generate the actual code for them so that they don't have to learn all the intricacies of how to create a table on Impala. So the create table commands is like 4 or 5 pages of manual, etc. Why not just generate the code for them? So we generate the create table code, and in our upcoming release, we generate the partitioning recommendations. The biggest problem on Hadoop style database processing is how do I partition the table? It can make or break your entire experience. We have customers who say, oh, Hadoop doesn't work. What happened? There was a large fact table. I didn't, they don't say I didn't partition it. We go in there and they haven't partitioned the table at all. Sort of defeats the whole purpose of having a distributed system if you've not partitioned it. But you can't blame the customer. It's a very big table with 200 columns. How do I decide what to partition it with? So we're building a partition designer in to tell them, to help them partition the table correctly.